Hi friends, welcome to the channel JV and CIV Made Simple. So this is our unit number 6 of AVM theory portion, and we are talking about the theories of probability. So we'll talk about it. So let's see the topic which we have to go through: objectives, introduction to probability, mathematical definition of probability, conditional probability, random variable, probability distribution of random variable, expectation and standard deviation of random variable, binomial theorem, Poisson's distribution, normal distribution, credit risk, value at risk, and finally we will discuss something called option valuation. Right, so this is what we call option valuation. Okay, so these are the 12 topics which you have to go through. Probably this chapter will be finished in 3 to 4 lecture. So this is the part 1 lecture of it. Let's discuss it. Let's start with the introduction to probability. So what is probability? It is just a fancy way of talking about the chance or likelihood of something happening, right? So this is just a fancy way of saying that a chance of something happening. This is what we call probability. Think of it like checking the weather forecast before your weekend picnic. So we are planned for a weekend picnic. So before beginning your weekend picnic, you check the weather forecast. So basically, in simple word, we can say chance of happening something. So chance of happening, this is what we call as probability, right? So if the forecast say there is 60% chance of rain, you can say the probability of rain is 0.6, right? So if the forecast says that there is 60% chance, you will say probability is 0.6. So it is just like this. Probability help us measure how likely something is to happen. But here is the cool part. It is not just about weather. It is the tool we use in all sorts of situations. Now let's talk about some important concept to understand probability better. That is factorial, permutation and combination. 3 concepts which very much important to understand this probability concept better. Let's remind it. I think you know it very well, but let's remind it. First of all, factorial. Factorial sounds complicated, right? But don't worry, it is simple. Factorial is just multiplying a number by all the number below it. So it just means multiplying a number by all the number below it, right? So like you can see, for example, if we talk about 5 factorial, so what is the meaning of 5 factorial? What is the number below 5? 1 2 3 4. So you just multiply 5 with all the number below it. That means 1 into 2 into 3 into 4, which gives us 120, right? So the cool part is some number have a special factorial. Like if we ask you about what is the meaning of factorial 0, it is 1. What is the meaning of factorial 1? It is also 1. Seems odd, but that is how the math work, right? So if we talk about what is meaning of n factorial, so write all the number below n, like n, and multiply it with the n. What are the number below n? N is an integer, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, multiplied by 2 into 1. So multiply all of them with n, you will get n factorial. So this is how you find the factorial. Suppose you want to find factorial of, suppose let's say you want to find factorial of 9, right? So how do you find 9 factorial? So 9 factorial is equal to 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? Now then we have something called permutation and combination. So permutation are all about the order of the thing, right? When we talk about permutation, it is all about the arrangement, or we can say order of the thing. So it is all about the order of thing. So let's say you have 3 books, right? Let's say you have 3 books, and you want to know how many way you can arrange 2 of them. So how many way you can arrange 2 books out of 3? So we can write it like either you can write p oblique 3 comma 2, p under bracket 3 comma 2, or we can write it 3p2. This is another way of writing it. Permutation. Order matter here. So in permutation, remember order, or we call it arrangement, it always matter, right? So that is permutation. Now combination on the other hand are about grouping things together. So combination is just about grouping things together. So if you had those same 3 books and you just want to know how many way you can pick 2, that is a combination. The order does not matter, only the selection. So to sum it up, probability help us measure chance, factorial help us calculate arrangement, and permutation and combination are different way of looking at how things can be arranged or chosen. If it is arranging, then permutation. If it is choosing, then it is combination, right? So let us talk in detail about this combination and permutation now. So in simple terms, permutation is about arranging book on yourself, where the order of the book makes a difference, right? So for example, let us take an example. For example, you say that you have 3 books. The book number A, book number B, book number C. These are the 3 books you have. if you want to arrange two of them at a time, so how many different way can be possible? Either you write AB, or you write BC, or you write AC, right? Or you can write BA, right, where order matter. We write CB, or you write CA. So there are 6 possible way to do it. See how the order change, and that is why it is called permutation. AB and BA is not same, because first book number A is kept and then book number B, but in this case first book number B and then book number A. So order matter here, right? Now what is the formula? The formula for permutation look like this. Sorry, let me write it down clearly. So NPR is equal to factorial n upon factorial n minus r, right? This is how we write it. So let's talk about combination now. You know combination, this one is bit different. Why? With combination the order does not matter. So order does not matter. What matter is just choosing the item. For example, let's take an example. It is like picking your favorite topping for a pizza, right? Whether you pick olive first, or you pick mushroom first, does not change what you have, right? So for example, if you have 3 objects, suppose 3 objects are A, B and C, you just want to choose 2 at a time. So how many ways you can choose 2 at a time? So you can choose either AB, you can choose either BC, or you can choose either AC, right? The order does not matter here. Either you choose BA or AB, does not matter. So that is why this is just a selection. You have to just choose 3. So the formula for combination is, you know, is quite simple. NCR is equal to factorial n upon factorial r into n minus r. We divide by factorial r, because you know combination is always less than permutation. That is accountable by, that is taken into account by this factorial r division. Now here is an interesting part. There is a relationship between permutation and combination. You know this relationship, right? You can actually calculate permutation using combination. If you know the combination, you can calculate the permutation. How that? You see, this is the relationship. I just told you that if you divide any permutation, sorry, let me write it down clearly. If you divide any permutation by the factorial r, you will get combination. That is how you will relate both of them. Now let's do some example to make this concept more clear. For example, how many way can 3 pencil be selected from 5 pencil? So whenever you see this word selection, you think of it combination, because its order does not matter here. Either we select pencil number 1 first or pencil number 2, it does not matter. So P1, P2 is always the same. So how many pencil we have? 5. How many we have to select? 3. So n is equal to 5, and you know r is equal to 3. So the formula is NCR, which is equal to how much? So NCR is equal to factorial n upon factorial r into 1 minus r, right? So let me do it for you. Just wait a minute. So 5 factorial 5 divided by what is r? Factorial 3 factorial 5 divided by factorial 3 into factorial 2. So see, 5 factorial means what? 1 into 2 into 3 into 4 into 5, right? And factorial 3 means what? 1 into 2 into 3, and factorial 2 means 1 into 2. So this and this will get cancelled. So this means 4 into 5 divided by 2. So this will give you how much? This will give you 10. So this 10 is the answer. There are 10 way of selecting, doing that. Now you see, from a group of 7 boy and 6 girl, how can 3 boy and 4 girl be selected? Again there is selection. Order does not matter. So you have a group of 7 boy. So what you do here, you will understand the concept of multiplication theorem. It says that suppose we have to do 2 work number A and work number B, and final work will be done when both are done individually. So to find the probability of final, let's say C, you have to find probability of A, you have to find probability of B, and then you will get multiply both of them, you will get probability of C. So here the similar thing is happening, that we have a group of 7 boy, we have a group of 6 girl, we have to select 3 boy and 4 girl. So there are 2 work to be done. The first work is to selecting 3 boy from the group of 7 boy, second work is to select 4 girl from the group of 6 girl, and after doing these 2 work, we will do the final work. So first we will find their probability individually. So what is the probability of selecting 3 boys from a group of 7 boy? It is nothing but 7C3, which is denoted by factorial 7 upon factorial 3 into factorial 4. So this will give you 5 into 6 into 7 upon 1 into 2 into 3. So it will give you 35 way. Similarly, if you want to select 4 girl from a group of 6 girl, it can be done in 6C4 way. So factorial 4 upon factorial 4 into 2. This will give you 5 into 6 upon 2. This will give you 15 way. Now you know how many ways are for boy and girl, so you have to find the combined probability, which will be nothing but multiplication of both. I told you this is called multiplication theorem. Please don't add. Most of the time I have seen some people doing mistake by adding. No, you don't have to add them, you have to multiply them. So what you need to do, you need to multiply with this 15 with 35, and as a result you will get 525 ways are there. I hope this makes sense. So that is how permutation and combination work together. This might seem tricky at first, but once you understand the basic idea, it becomes some simpler. So to sum it up, permutation is for arranging things where order matter. Combination is for selecting things while order does not matter. And again, you can use this formula together to solve problem. Now let's talk about the random experiment or trial. So let's start with the random experiment. What is the meaning of this so-called random experiment? In simple terms, random experiment is just any action or operation that you perform under identical condition, but it can lead to different outcome. You probably heard, you are probably already doing random experiment without even thinking about it. For example, let's say you are tossing a coin. So every time you toss it, the result could be either head or result could be either tail. Or think about throwing a dice. So each time you could get a different number like 1, 2, 3, 4, 5 and 6. So even picking a card from a deck is a random experiment. So what is the peculiarity of random experiment? That you perform under identical condition. Any action or any operation you perform under identical condition, right? But it leads to various possible outcome. It leads to different outcome. That is what we call random experiment. Now, so what happened after the experiment? So we need to talk about something called the sample space. So after you perform the experiment, what will happen then? Then we will to talk about something called sample space. Let's talk about it. Let's talk about the so-called sample space. So a sample space is a fancy term for all possible outcomes that can happen in a random experiment. You have performed the experiment, outcomes are there, and these outcomes are called sample space. So right. So let's take a coin toss. For example, the possible outcomes are HT, head tail, right? So the head or tail. So the sample space is simply HT. So if we throw a dice, the sample space would be the number we could get, like 1, 2, 3, 4, 5, 6. So this is called sample space, right? So there are 6 possible outcomes. So this is noted by NS. N under bracket S, it means number of sample. It's just a fancy way of saying number of outcome. This is a fancy way of saying number of outcome, which is how much? 6. Now within the sample space, we can pick out something called an event, right? So within a sample space we can pick out something which we call event. An event is just a specific outcome or a group of outcome we are interested in. For example, let's say we are rolling a dice and we want to know how many odd number we can get. So our event will be how much? So our event will be 1, 2 and 3. This will be our event, right? Because those are the odd number on the dice. So in simple word, sample space is all the possible result of an experiment, and an event is just a group of those results that we care about. All event. So imagine you are rolling a dice. You know the possible outcome. What are the possible outcome when you are rolling a dice? So either you can get 1, 2, 3, 4, 5, 6, right? So these are the possible outcome while rolling a dice. So that is your sample space, right? So this 1, 2, 3, 4, 5 and 6 are your sample space. You can see it here. So this S denote the sample space and these are our sample space. So meaning all possible result in the experiment is called the sample space. Whatever possible result is there is called sample space. Now an event is simply any selection of the number from this set. So this is a set and you select any possible number from this set is called event. For example, if you are interested in getting odd number, right? So your event will be how much? 1, 3 and 5. So any possible selection of number from this set is called event, right? So event of getting odd number is equal to 1, 3 and 5. Simple. Now let's talk about the types of event. The first type of event is called certain event, which means something that is guaranteed to happen. For example, rolling a dice and getting a number between 1 to 6. Obviously, no matter what, you will always get a number in this range. So this is a certain event. Second kind of event we have is called impossible event. What is the meaning of impossible event? It means an event that can never happen, right? Just like rolling a dice and getting a 7. Well, that is impossible unless we invent a magic dice, right? Then we have something called mutually exclusive event. Very, very important. See, those events that cannot occur together, that cannot happen together, this is called mutually exclusive event. For example, you are tossing a coin. So you are tossing a coin, right? So you either get a head or you either get a tail, right? You will either get a head or you get a tail, but never both at the same time. So event A denotes getting a head, event B denotes getting a tail. So this A and B are mutually exclusive event, right? So this is noted by A intersection B is equal to phi. Phi means null event. This means null event. Means what? There is no intersection of A and B. That means you can never get both at the same time. That means event A and B cannot occur at the same time. So either you will get head or you will get tail. You will not, there will be no situation where you will get both head and tail at the same time. That is why these two events are called mutually exclusive event, means they cannot happen together, right? For example, tossing a coin. Then we have something called equally likely event. So when all outcomes have equal chance, right? For example, you have roll a dice, each number 1 to 6, each number 1 to 6 have the same probability of showing up. Like if I say A is the probability that 1 will show up, which will be 1 upon 6. B is the probability that 6 will show up, this is also 1 upon 6. So we can see that probability of each number occurring is same, right? So that is called, they are called equally likely event. Then we have something called exhaustive event, which means when event together cover all possible outcome. So when events together cover all possible outcomes, right? For example, if we list all possibilities of a dice roll, what can be the possibilities of a dice roll? Either 1, 2, 3, 4, 5, 6. These are the possibilities of a dice roll. So we have covered everything. That is an exhaustive event, right? So understanding event is super important in probability, banking risk and CAIIB examination. So now that you have got the basics, try thinking of real life example and drop them in the comments. Now let's talk about something called understanding the probability events. Very important from examination point of view. So let's understand the probability event. So a probability is all about predicting chances. So whenever I say this word probability, it means we are predicting what? We are predicting the chances. So think of it like this, tossing a coin. So right, tossing a coin, either you get head or you get tail, right? So there are two possible outcomes. So that is what is represented by NS. NS means number of sample space is 2, right? Then number of elements in sample space is 2. Similarly, if you are rolling a dice, means how many possible outcomes are there? 6. 1, 2, 3, 4, 5, 6. So this is represented by NS is equal to 6. So the set of all possible result is called sample space, right? The set of all possible event is called sample space, and event is called just a selection of outcome, right? And already we have talked about the types of event, like certain event, impossible event, mutually exclusive event. Just now we have talked about it, right? Then we have something called complementary event. Let's talk about it now. What is the meaning of this so-called complementary event? And okay, complementary event means what? So there are pair of event. These are the pair of event that where one happen if the other does not happen. So they are like mutually exclusive. So we are talking about this so-called complementary event. So they are something called mutually exclusive. These are the key point. Means can't happen together, and also they are exhaustive. Exhaustive means that cover all possible outcome. So let me give you one example. For example, let's say we define event A as rolling 1 or 2, right? So we have rolled a dice and getting 1 or 2 is event A, and let's say event B is what will be the complementary event? The complementary event will be 3, 4, 5, 6. Means these are the pair of event where one happen if the other does not, right? So before that you must understand what is the meaning of this exhaustive event. You see this word written exhaustive. Exhaustive means what? Imagine you are rolling a dice. The possible outcome are 1, 2, 3, 4, 5, 6. Now if you consider different event but together they cover all possible outcome, we call them exhaustive. Think of dividing this outcome into groups like 1, 2, like 3, 4, like 5, 6. So we have divided into 3 groups. No matter what happened, the final result will always fall into any of these group, meaning we have covered everything. That is called exhaustive event. right? So if we complementary event, these are the pair of event where one happen if the other does not, means they are mutually exclusive, means what, can't happen together, and they are exhaustive, means they cover all, right? Say we define event A as rolling as 1 or 2, the complementary event B will be getting 3 4 5 6, right? You can see it here. So together A and B cover all possible outcomes, that is why A union B, this is the symbol of union. Union means what, A union B. A union B is equal to our sample space. So whenever two events are such that their union is equal to sample space, those two events are called exhaustive event, means they cover everything. And also A intersection B is what, phi. Phi means what, null event, means there is nothing common, they can't happen together. So the complementary event is denoted by, there is a notation of denoting it, either you denote by A bar or you denote by AC. So both represent the complementary event. So suppose I want to write complementary event of B, it can be denoted as B bar, or we write it BC, right? So this way we can denote the complementary event. Now let's talk about the mathematical definition of probability. How do we define probability? Let's talk about it. So how do we calculate it? Probability of an event A happening is equal to, the formula is quite simple. You write favorable outcome in the numerator, you write favorable outcome in the numerator, and you write total outcome in the denominator, total outcome in the denominator, and this ratio will give you probability, right? For example, let's take an example. Suppose you roll a dice, right? So you want an even number, so okay, tell me, so what are the elements included in the even number? Suppose A is the set, so it can be 2 4 and 6. So there are three favorable outcome, and total number of outcome is how much? Sample space will contain 1 2 3 4 5 6, right? So what is probability of A occurring? It is nothing but 3 upon 6, or we write it 0.5, right? That is what it is, right? So you roll a dice, you want an even number, there are 3 possible outcome and 6 total outcome, so probability is 0.5 or 50%. So the key rule is that probability always lie between 0 and 1. It can be equal to 0, it can be equal to 1, right? So let me tell you, suppose probability is equal to 0, what does it mean? It means the event is impossible, it's not possible. And if I tell probability is equal to 1, what it means? It means that it is a certain event, the event is certain, right? So final thought, probability is in everywhere, in banking, risk, investment, and of course in your CAIIB examination. Now I hope you have a clear understanding. So let us move through some examples to make it more clear. So what happened when you roll 2 dice? Let's solve 3 probability scenarios step by step in simplest way possible. So the first scenario is you have 2 unbiased dice are thrown. You have thrown 2 unbiased dice. So the first scenario is find the probability that both dice shows the same number. Imagine you roll 2 fair dice. What is the probability that both will show the same number? So step 1 is the total outcome. So tell me, each die has 6 faces, you know it. How many faces are there? 6 faces. And we roll 2 dice. How many dice we roll? We roll 2 dice, right? So total number of possibilities can be how much? Tell me. Total number of possibility is how much? So we write it, we denote the total number of possibility by ns, which is equal to 6 times 6. I already told you in the previous lecture, and this is called multiplication theorem. If suppose our total result depends on 2 outcomes, so here 2 outcomes are rolling first die and rolling second die. How many possible events are there in for rolling first die? 6. How many possible events are there in rolling second die? 6. If we our total outcome will depends on these two, so we multiply both of them. This will give us the total number of possible outcome, which is noted by ns. Now this is the first thing we have to always do, is to calculate the total number of outcomes. So we have to find the probability that both dice shows the same number, right? Step 2, we have to calculate the favorable outcome. So it means both dice show the same number. So what are the possible event? So either it can be 1 1, either it can be 2 2, either it can be 3 3, or it can be 4 4, or it can be 5 5, or it can be 6 6. These are the favorable outcome. So how many cases are there? There are 6 cases, isn't it? So what is the formula for probability? Probability, or PA, probability of occurring of event A, is equal to favorable outcome upon total number of outcome. So what is favorable outcome? 6 upon 36, which is equal to 1 upon 6, right? Which is almost equal to 16.67. So I hope this is clear now. We have find the probability that both dice shows the same number, right? Okay, now let's look at the second case. The second case is that the first die shows 6, right? This is the second question. Let me show you. This is the second question. The first die shows 6. Let's answer it. Now what is the probability that first die shows a 6 no matter what the second die shows? Step number 1, we have to find the total outcome. Always remember, always do it step wise. We have to find the total outcome. So again we have 36 possible outcome, so ns is equal to 36. Now for the first die to be 6, the second die can be anything from 1 to 6. So it can be, possible event can be 6-1, 6-2, 6-3, right, 6-4, 6-5 or 6-6. So how many possible number of events is there? 6 cases are there, and we know what is probability, number of case upon total number of favorable outcome upon number of outcome. So you know 6 number of favorable outcome are there and 36 number of total outcome are there, so it become 1 upon 6. So probability of B, let's say it is B, probability of B is 1 upon 6. I hope it is clear. Now let's look at the scenario number 3. The total number on the total of number on the dice is 8. So this is the third question. How to find it? So let's do the calculation here. How to find it? So 8, exactly 8. So total number of outcome is still 36, right? This is the step number 1. Step number 2, we have to find the favorable outcome. How to add? Okay, what are the two possible cases? So that sum is always 8. So either it can be 2-6, either it can be 3-5, or it can be 4-4, or it can be 5-3, or it can be 6-2. How many cases are there? I think 5 cases are there. There is no any other case which can make the sum 8. Right, so favorable case is 5, total number of cases 36, so 5 upon 36 is our probability. So I hope it is clear. So probability is all about breaking things down logically. This is exactly how risk and decision making work in banking, right? Now let's look at some other cases. So example number 2, probability with 2 unbiased coin. I think we have discussed the first question. Let's look at the second question. The second question is probability with 2 unbiased coin. Let's talk about coin now. Flipping 2 coins. What are the chance of getting at least? So the question is getting at least one tail. This question will be asked. Suppose you flip 2 coins, right? What is the chance of getting at least one tail, right? So first of all, let's find the chance. At least one tail. So how many possible outcomes are there? 2 coins are there, right? How many possible outcomes are there? Either it can be HH, or it can be HT, or it can be TH, or it can be TT. There are 4 possible outcomes. So our NS is equal to 4. Now what are the how many events are possible when we have at least one tail? So you see, here is one tail, here is one tail, here is one tail. So our favorable outcome is 3, right? So our probability will be 3 upon 4. Favorable outcome upon number of event, so it will be 3 upon 4. Now second question is majority of head. Denominator will be 4, but majority of head means maximum will be head, so only one case is there, HH, so 1 upon 4. So I hope this make your concept clear. Let's look at the third example, probability with balls. Now imagine a ball with white and black ball. Sorry, imagine a box. So there is a box, right? Inside it you will see there is a white ball and there is a black ball. Okay, now what are the chance of picking a certain combination? So I hope the question is not given clear. So let us move to the next question. Yes, so let's look at example number 5, probability with letter in random. So you know how many letters are there in random? 1, 2, 3, 4, 5, 6. 6 letters are there. What is the probability that letter A and O are extreme, right? So letter A and O are extreme. How many cases are possible with letter A and O are extreme? How to solve this question? This is the question of probability, permutation, right? So first of all we have to find number of possible outcomes. So how many possible outcomes, how many way you can arrange this letter? So there are 6 letter, right? There are 6 letter. So we can arrange this 6 letter in factorial 6 ways. Factorial 6 ways it can be arranged. And if you find factorial 6, how much there will be? 1 into 2 into 3 into 4 into 5 into 6. What is the multiplication? So you can see 5 into 6 is 30, 30 into 4 is 120, 120 into 3 is 360, 3 is 720. So 720 number of possible outcomes is there, right? And now what is our favorable outcome? Our favorable outcome is there that A and O should be at extreme. So suppose I fix A and O here, right? And in between how many number are there? 4. So this can be arranged in factorial 4 ways. And similarly I fix O here and I fix A here. This can be arranged in factorial 4 ways. right? And our work will be done when both work will be done, so we have to add both of them. So what is the value of factorial 4? Which means 1 into 2 into 3 into 4, which means 4 into 12, 12 into 24. So 24 plus 24 is 48. So number of favorable outcome is 48 and total number of outcome is 720. So this 48 upon 720 will be our probability that letter A and O are extreme. So you must understand what is the meaning of permutation. Permutation means number of possible arrangement, right? So factorial 6 is the number of way taking one at a time, right? Taking one at a time, taking all the 6 at a time. So you know what is the how many ways this letter 6 letter can be arranged taking all 6 at a time. So 6p 6 ways, which is factorial 6 upon factorial 0, which is factorial 6 upon 1, which is factorial 6 ways. Is it clear? I hope it is clear now. Let's look at the next example. Probability with letter in squares. How many possible outcomes are there? 720 ways. Now let's see, first letter is vowel. So let's explore this case, right? First letter is vowel. So there are 720 ways which we can arrange this letter. How we get 720 ways? It's quite easy. You find this 1 2 3, there are 6 letters of factorial 6 ways. Now first letter is vowel. Tell me how many vowels are there? A, E and U. 3 vowels are there. So the first letter is always A, E and U. So the first letter can be filled in 3 way, and we have rest 5 letters, right? So these 5 letters can be arranged in factorial 5 way, and the first letter can be arranged in 3 way. So our possible favorable outcome is 3 into factorial 5. That is what it is written, which is none but 360. So probability will be 360 upon 720, which is equal to 0.5. Now let's look at the next question, that vowels and consonants are alternate, starting with a consonant. So our first letter will be consonant, right? Next letter will be vowel, next it will be consonant, it will be vowel, it will be consonant, it will be vowel. This is how it is talking about. So tell me how many consonants are there? You see S is consonant, you know consonant, A, E, I, O, U is vowel, except that everything is consonant. Q is consonant, R is consonant. So first can be filled in 3 ways. First can be filled in 3 ways, right? So factorial 3. The number of ways can be done in factorial 3. Similarly, second can be filled in also 3 ways, right? This is a nice question, right? So a possible arrangement is 3 into 3, factorial 3 into 3, which is 6 into 6, which is 36 way. So it is 0.05. Now let's look at the addition theorem in probability. What is the addition theorem in probability? So friends, imagine you are running a bank and needs to analyze customer data. Some customer have saving account, some had fixed deposit, and some have both. How do you calculate the probability of a customer having at least one of these? That is where additional theorem comes into picture. So let's talk about this addition theory. Some people are having saving account, some are having fixed deposit account, and some are having both. How do you calculate that the number of people who are having at least one account? So to calculate that, we use addition theorem. So it is denoted by P A union B is equal to PA plus PB minus PA intersection B. In simple terms, if you add the probability of 2 events, you might be double counting their common part. So suppose this is first event, this is the second event. If you add both of them, you are double counting this common part. This is the common part which I have highlighted by the marker, right? So this is the common part. You are basically double counting this common part, right? So we subtract it once. That is why we have subtracted, and this is called A intersection B. So we have subtracted this A intersection B part, right? So I hope it is clear. Now let's look at the case number 1. Event that cannot happen together, right? That means they are mutually exclusive. So when 2 events cannot happen together, they are called mutually exclusive event. You know it very well. Now what if 2 events can never happen together? Like rolling an even and odd number on a single dice roll. So if A and B are mutually exclusive, it means their intersection will be 0. So in that case, PA union B will be equal to PA plus PB. For example, let's take an example. You are rolling a dice. So probability of getting 2 or 5. So what is the probability of getting 2? It is none but 1 upon 6. What is the probability of getting 5? It is also 1 upon 6. And what is the probability of getting 2 or 5? It is nothing but 1 upon 6 plus 1 upon 5. Because there is no commonality. There is nothing common in between. That is why you add both of them. Right? Because 2 and 5 cannot happen together. Now case number 2. When 3 events are involved, what about that? So when we have 3 events, like customer having a saving account, fixed deposit account, and a loan, 3 cases are there. So in that case, the formula is PA plus PB plus PC, this you add them individually, then take intersection 2 at a times, minus PA intersection B minus PB intersection C minus P intersection C plus PA intersection B intersection C, right? So let's take an example. Probability A represent the customer has a saving account, probability B represent the customer has a fixed deposit account, and probability C is the customer having loan account. Since some customer might have multiple product, we adjust by subtracting the overlap and adding the case where all the three happen together. This help in real banking decision like analyzing cross-selling opportunity. And if we talk about the case number 3, which is understanding probability using complements. What if you want to find the probability of A happening but in two different way? So in that case we have to do PA is equal to PA intersection B plus PA intersection B complementary. This means what? A happen when B happen, and or we say A happen when B does not happen. For example, probability of a customer applying for a loan. This suppose it is A. A is the probability of customer applying for a loan. Now some apply because they already have a saving account, which is a B. B means they already have a saving account. And some apply without a saving account, which is B complementary. Having a saving account is B event, and B complementary is not having a saving account, right? So adding both the case gives the total probability of loan applicant. Suppose we want to find how many loan applicants are there, right? So A represent the probability that there is a loan account. Now A intersection B means A happen when B happen, means what? A means what? Some people apply for loan because they have a saving account, and some people apply for loan because they don't have a saving account. So if you want to find total number of loan account, total number of loan applicant, which is equal to sum of these two, right? So real world application, let me give you why this matter in banking, because risk analysis, calculating default probability for loan, you can calculate it, fraud detection, overlapping pattern in suspicious transaction, customer targeting, right? So this way you can help it. Now let's look at the 4 corollary, that is AC is a complementary event of A. We will discuss all these things using example. So corollary are like shortcut in probability. What is the meaning of this corollary? These are the shortcuts in probability, right? This help us solve problem faster without going back to the basics every time. Let's go through one by one. So you can see complementary event. So if event A does not happen, then it complementary event AC happen, which means probability of AC is equal to 1 minus probability of A. For example, if the probability of customer taking a home loan is 0.7, so the probability of not taking a loan is 1 minus 0.7, which is equal to 0.3. This is useful in banking when calculating default risk or fraud detection. Then we have corollary number 5, which is probability of B and complement of A. If you want to know the probability of event B happening but A does not happen, we have the formula PB intersection A complementary is equal to PB minus PBA intersection B. For example, imagine a bank check how many customer have a saving account, which is our A. How many customer are having saving account, that is our event A, but not a fixed account, which is suppose it is B. Suppose having saving account is noted by event A, and not a fixed account is noted by it is B. Suppose having not a fixed account noted by AC. So they subtract those who have both, and that gives the only saving account holder, right? Then we have if A is a part of B, A is always less probable. Suppose A is a smaller event. So when I say A is a this is a part of B, right? A is a smaller event, right? A is a smaller event inside B, then its probability is always less than or equal to B. That is what is denoted. For example, A is a customer having both a saving and fixed deposit. B is a customer having at least one of them. So it means B includes A, right? And then we have probability of neither A nor B, which is our corollary number 7. Let's see. Probability of neither A nor B, right? So this can be represented by probability A complementary, B complementary, intersection is equal to 1 minus PA intersection B. For example, if A is the probability that customer taking a home loan, right, and B is the probability that customer taking a car loan. What is the probability? A complementary, B complementary is equal to customer who take neither loan. This helps in analyzing customer who may need a future loan after. Now let's move to the super important concept, which is our conditional probability. This tells us probability of A happening when B has already happened. That event probability of event A when B has already occurred, right? The formula is quite simple. it says that PA given that B has happened is equal to PA intersection B upon PB, right? Think of it like this. What is the probability that a customer will buy insurance if they already have a loan? What is the probability of a second default if the customer has already defaulted once? Real world example. Let me give you an example to make it more clear. For example, a bank find that 60% of its home loan customer also take LIC, life insurance policy. If a customer has a home loan, then the probability of them taking insurance is 60%. So conditional probability is used in fraud detection, customer targeting, credit risk management, right? And there is an important theorem, right? There is an important theorem called multiplication theorem, which means linking two events. Try to understand it. So let's look at how probability of two events multiply when they depends on each other. You can denote it mathematically by this: probability A intersection B is equal to probability of A multiplied by probability of B given A at occur is equal to probability of B multiplied by probability of A given B occur. Think of it like this: probability of customer taking a personal loan and then taking a home loan, that is what this is, right? Probability of a stock price rising and the company declaring a bonus. For example, a bank find that 30% of its customer takes saving account, that is, suppose it is our probability of A, and also out of those 40% also, let's say a bank find that 30% of the customer takes a saving account, let's denote it by A, right? And also you find that out of those 40% also take a credit card, right? So let's denote it by B given that A has occurred. This is noted by probability of B given that A has occurred. B means taking credit card. So using multiplication rule, we can say that P A intersection B, right, which is equal to multiplication of both, that is PA multiplied by PB intersection A, which is nothing but 0.3 multiplied by 0.4, which is equal to 0.12, means 12% of all customer have both of them, right? So that is called PA intersection B. A means having saving account, B means having credit card. So what is the probability that a customer have both saving account and credit card, which is equal to, first you multiply the probability of having only saving account and you multiply it by probability of having credit card given that saving account is there, which is equal to 0.12, right? So this is used in customer profiling and predicting future banking needs. So I hope this make your concept clear. Now let's talk about independent event. We will do numerous example to make all this concept more clear. Let's first understand the concept. What is independent event? So friends, in probability, event are called independent when one event happening does not affect the other. Let's take an example, like tossing a coin twice. Suppose you toss a coin twice, right? The first toss has no effect on the second toss. Like rolling two dice. Suppose you roll two dice. What comes on one die does not affect the other. So a customer opening a saving account and buying a home loan might be independent event if they are not related, right? And what is the formula for this independent event? It is PA intersection B is equal to probability of A multiplied by probability of B. This is useful in banking when calculating risk that don't depends on each other, like a customer taking two separate type of loan, right? Now let's start with the first example that we have. Let's apply this concept to the real life scenario, like drawing a card from a deck of 52 playing cards, right? Let's understand. Find the probability that the card drawn from a deck is either a red card or a picture card. So either red or picture card. The first step is to define the event. You must define the event first. This is the first step. So let's say A event means drawing a red card. Okay, what can be red card? It can be heart, or it can be diamond. And option B, say let's B is the event that drawing a picture card. So it can be king, it can be queen, or it can be jack of any suit. This is the first step. We have to define event. Now the second step is to find their probability, find individual probability. Now let's talk about red card. You know how many red cards are there? So out of these 52 cards, you know there are 26 red card and 26 black card. I think you know it, right? Very well, very nice. So how to find probability of A? Drawing a red card, number of favorable outcome is 26 and total number of possible outcome is 52. So it is 1/2. That is called probability of A. And if you want to find probability of B, which is total picture card, you know it very well that 26 total picture card. How many picture card are there? There are 12 picture card, right? So how do you know there are 12 picture card? I think you know it very well. Heart, diamond, spade, right? So there are 12 picture card. So 12 in the numerator and 52 is the total outcome, which gives you 3 upon 13, right? So 12 picture card, which is equal to 3 upon 13. Total picture card is 3 upon 13. Now if I ask you, the question is that card drawn from either a red card or a picture card. So red picture card. So what will the probability of red picture card? It will be how much? It will be just 3 picture card multiplied by 2 red suit, because only 2, so 6. So PA intersection B is equal to 6 upon 52, right? So PA intersection B is 6 upon 52. So this is about the card, right? So PA intersection B is equal to 6 upon 52, and applying the addition rule, we know it, PA union B is, because either or always represented by union, either picture or red. This means we have to talk about union. So PA union B is equal to PA plus PB minus PA intersection B. This is what we have learned earlier, and we are applying the formula here. So what is PA? 1 upon 2. What is PB? 3 upon 13. And what is PA intersection B? Which is drawing a red picture card, which is 6 upon 52. So let me tell you why it is 12, because once you have the understanding of these basics, then you can easily interpret it. Why we get here 6 red or picture card? Let's try to understand. See, 50 out of those 52 cards, right, it is divided into 4 parts. The first is called spades, the second is called club, the third is called heart, the fourth is called diamond. So there are 13 spades, 13 club, 13 heart and 13 diamond. Out of this 13, 1 to 10, 1, 2, 3, 4, 5, 6, 10. 10 is called ace, and remaining 3 is king. Remaining 3 is king and queen and jack. Similarly here also 1 to 10, remaining 3 is king, queen and jack, right? Similarly 1 to 10, remaining 3 is king, queen and jack, and here also 1 to 10, remaining 3 is king, queen and jack. Now question is red or picture card, right? So how many picture cards are there? How to find P intersection B? Means it should be red and it should be picture card, right? So there are 6 possibility, because spades and club, heart and diamond are red and spades and club are black, it very well. So first of all, there are 26 cases when there is a, but we are talking about red, so heart and diamond are red, so 26 cases. Out of this 26 case, 3 cases in heart and 3 cases in diamond are there when we have picture card. So total 6 cases are there. That is why PA intersection B having red picture card is 6 upon 52. I hope this is clear now. Now we have to find union, which is nothing but PA plus PB minus PA intersection B. After calculation, this gives us 8 upon 13.